Hey everybody, welcome back to the Digital Making at Home live stream for this week. I'm coming at you from a different place this week. I'm up in the Peaks District National Park in the United Kingdom, so that's a bit north of where I usually live in Cambridge. So I'm off and away in a cottage somewhere in the middle of nowhere. The cottage I'm in right now is about 500 years old, I think. So it's a little bit different for me, so you have to excuse me if I'm a little bit off my game compared to usual. But we'll be doing exactly the same things. We've got some coding this week. We're going to be doing some stuff with machine learning, which is really, really cool. Nice sort of advanced application of our coding knowledge. But we're going to pair it up with Scratch, which is something that we all know and we all understand, and something that can be really nicely adapted to doing this sort of thing. So we're going to build a machine learning model, and then we're going to adapt that into Scratch. We're going to use Scratch to do some cool coding stuff with it. I'm going to have Carrie Ann Philbin on with us a bit later on today, and she's like a really cool person who I work with at the foundation. She's going to have some great stuff to talk about, the things that she's done for inclusion and all sorts of things in computer science over the last few years. And I'm also joined by Sophie again. You might remember Sophie previously from when we talked about turtles and we had the turtle and pollution game, and Sophie came on and we started making broccoli lasers and all sorts of awesome stuff like that. So we've got Sophie back this week to do some machine learning with us in the Alien Language project. So what we'll do now is we'll get Sophie on and we'll start doing some really cool machine learning stuff. So Sophie, where are you? Hey, how's it going?
I'm good, how are you?
I'm not too bad, actually. My feet are a little bit cold in this like really old stone cottage, I have to tell you, though. But it's all right. So it's apparently supposed to be a heat wave in England soon, so that'll be nice. And I hear you're off on holidays from school soon.
Yeah, tomorrow.
Nice. Are you looking forward to it?
No.
No, okay. Why not? Everyone loves holidays.
It means loads of room tidying, which
Right.
isn't as enjoyable as sleeping in.
Fair enough, right. But is there not like a whole bunch of like room messying up before it has to be room tidying up again? Isn't the messying part the fun bit?
Yeah, if you don't count the bit at the end.
Nice. Okay, so your cat does all the messing up and you do all the tidying up?
Yeah.
Okay, cool. That sounds like a bit of a one-sided relationship to me. You should get the cat to do some tidying up one time. And then you can just like lounge around and sleep in boxes and stuff like the cat does. You should switch it up on holiday. Are you ready to do a bit of machine learning and stuff today?
Yeah, I am.
Yeah, awesome, cool. So I remember last time we came on, we threw a few new things into the mix in our Scratch project. So we'll do that as well today if we get a bit of time, eh? And we'll get started on that machine learning engine, because like not a lot of kids, I don't think, have had some experience with machine learning before. You had a bit of a play with it earlier. How did you find it when you just sort of like messed around with it? Was it tricky? Was it easy? Was it weird?
It was fun.
Yeah? That's cool. What did you like about it? What was the best thing about playing with the machine learning?
Probably the we didn't have to say all the gibberish words into the microphone.
Yeah.
And you got to say it again and again, or just shifted to a command.
Yeah, that's it, right? So like we give it a lot of examples of things to understand, and then it goes away and sort of learns that, and that takes a little bit of time. And then we can make it do whatever we want once we've spoken to it. So what we'll do, I think, is if you want to share your screen with us, we'll just crack on with the machine learning part. So for everybody at home, if you want to join in with me and Sophie, you can go to machinelearningforkids.co.uk. And then so the website will pop up in front of you and you'll see you've got these things here. And at the bottom, it will say try it now. So you can have a go at it without having to log into anything. You can just sort of like have a crack at it. So if you click that for me now, Sophie, we'll say try it now. And we'll just start up a brand new project without having to make an account with them. Cool. And then we want to make a new project. So add a new project. And we get this sort of thing here. It will ask us for what a project name is. So you can call it anything you want. So you can call it like Alien Language or something like that. Cool. And then we're recognizing. So what we want it to do is, so that's cool. We want it to be doing sounds, recognizing our sounds. Fantastic. And then you can just open that new project. Cool. So open that project for us. And we want to train it. So click on that box on the left. So we're going to train the machine to understand you when you're talking to it. Cool. And it opens up this little box in front of us, right? So it's asking for background noise now. So what we're going to do is you're going to train it. So you're going to click add example, and it's going to record a chunk of the background noise. So we need to be like quiet while that happens.
Okay.
Cool. Yeah, so add that one. And we'll do a couple. Do around about 8. 8 is a really good number of sort of samples to do because it's not too many. And it's also not too few. Really cool. All right, so let's do a couple more. I'll just be quiet now. Awesome. So now that we've got our background noise sorted out, what it's going to do with that is it needs a sample of what the general environment around you sounds like, so that it can subtract that from the things that you're saying. Because if you've got sort of like noisy trucks going past and people playing background music and stuff, if that's what it sounds like where you are, it needs to be able to pull that out of what you're saying so it doesn't get confused by it. So we've just given it some stuff and say, this is what it generally sounds like where I am right now. So if you hear this, that's not what you're looking for. Cool? So it's added our background thing. So what we want it to do now is you want to add a new label. Can you see on the right there it says add new label?
Yeah, got it.
Cool. And so what we want this one to be, so these will be the thing you're going to say. So we'll start with left and right, and then we can add like one or two other ones for you. Cool. So we get a new box that says left. And so it's exactly the same process, right? So we're just going to record you saying the word left 8 times at the machine while I be really quiet and just sit here silently and wait for that to happen. So exactly the same process. So down the bottom, we click the little button to add an example, and then you just say left at your microphone. And when you're done, you can stop it.
So do I have to say left, or can I just say any gibberish word?
It can be anything you want. I mean, this will be our command to go left on your screen. So if you wanted to say something totally different, right? If you want to say purple monkey dishwasher, then that's totally fine. Go for it.
So I can say any word I want, which is not in the English dictionary.
As long as it's not a rude word, yeah, go ahead.
Sploink.
Awesome. So now we need eight copies of Sploink.
Sploink. Sploink.
Awesome. And I like how you're varying up the way you say it too. That's really important, because if you say it exactly the same every time like a robot does, it won't have the variation it requires to sort of learn it if anybody else tries to say Sploink. It will only recognize you saying Sploink like a robot. So that's really good. Keep it up.
What, does this do? Like, it's a bit darker here than here.
So that's recognizing the sound pattern of what you're saying. So where the darker parts are, that's like a closer waveform or a larger waveform, and it's recognizing the sound as you're saying it. So if you have a look, at the beginning of your bits, you've got sort of like a blank part, and then the first part where you get that little dash of color, that'll be the spurt sound, and then at the end, it will be the unk sound. So that's the waveform picking up the things that you're saying. So if you click go and say Sploink as fast as you can, you should see the waveform shift slightly to the left.
Okay. Sploink.
See it shifted?
Yeah.
Yeah, cool. So that's basically the sound waves of what you're saying and the computer representing that in image form for you so that you can see how similar or different they are. And if you have a look, like you can actually see the different levels. If you put them all together, they look kind of like the same picture. Can you see there's almost like it looks almost like a number 2 to me in your picture, kind of.
Yeah.
And that's in all of them, right? Because that's the audio pattern of the thing you're saying represented in visual data.
Next one. Sploink. 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 Sploink.
Amazing. I love it. So now what you'll need another gibberish word for right. So you need to think up some random gibberish stuff and click add new label. And we're going to make a new training bucket. And we're going to call this one right because that's what it means. But you can make up whatever word you want. So what's the opposite of sploink in your language?
I don't know. Verbal. 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 Verbal.
Really cool. And we can see again that the waveforms look kind of the same all the way through verbal. Like they do look quite similar. It's really interesting, actually.
Verbal. Yeah, this one kind of looks like a leg at the bottom.
It does, yeah, it does. And I could see the last one you just did where you said it quite firmly, like you can see that it's darker all the way along, right? Like it's got a harder waveform all the way along.
Yeah. Sploink.
Oh no, that was meant to be verbal.
Oh, yeah.
That's the trick. That's the tricky part when you start making up words. They get confusing.
Yeah. Verbal. Right. Well, I forgot it. Verbal.
Awesome.
Okay, then.
All right. And so, did you want to add like another weird command, like for it to do something different? So we can make it move left, we can make it move right, and then we can make it do something else altogether. We just add a new label for that, and you can call that whatever you want it to be.
I'm not entirely sure.
Well, we were talking earlier about. Did you want to do a teleport with your alien when we get to it?
Yeah, I said. Right.
All right, cool. So give it the meaning of the word, because remember that when we say sploink and verbal and things, they can get confusing. So give it the meaning of the bucket. What do you want it to do when we tell it to do that?
We want it to teleport somewhere random.
Awesome, cool. So if you make this bucket and call it teleport, then we'll know what that is when we come to the project. It will be easy for us to give it commands that do that.
Okay.
Well, now the tricky part. Gibberish word that means teleport.
Zerp. 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 Zerp.
Cool.
Okay. Got it.
All right, cool. So we've got 8 of everything, and 8 is a cool number. You can do a lot more if you want to, but sort of like 8 is enough. If you start doing lots and lots of ones, so if we did like 8 left, 8 right, and then we did like 79 zerps, it would start to recognize most things as zerp. It would be a little bit biased towards the thing that we've given it a lot of information for. Hey, cool, there's your dog. What's your dog's name?
This is Aria.
Aria.
Aria, come.
Amazing. What kind of dogs are they? They're beautiful dogs.
Ooh, slower. They're Samieds.
Samieds.
These are the ones you cannot train, whatever.
They're strong personalities, are they?
Yeah.
Awesome. Well, they're so fluffy.
Yeah, it's the downside. You get stuck in absolutely everything. They like to take a bush home with them, so.
That's cool. Are they going to hang out with us while we do the coding part? Or they're looking
They
for more
might
snacks,
do.
I think.
They might do.
Again, strong personalities.
Yeah, they might do. They might not.
All right, cool. Well, we'll just let them crack on with whatever they feel like doing. It sounds like that's what they do most days anyway, right?
Yeah, they just sit there.
Awesome.
They stare as well. So.
Cool. So on your project screen, you should see a thing at the top left that says back to project.
What? So yeah. Right.
So just above your background noise bucket, you'll see one that says back to projects, like a little text link. That's it.
Yeah, got it.
Cool. So we've got all our stuff. So we've trained it on the things that we want. Now it has to learn the things that you've said. So you see that button in the middle that says learn and test?
Yeah, got it.
Click on that one and it will bring us through. It should tell you on the left that you've got like 8 samples of background, 8 of left, 8 of right, and 8 of teleport. Does it say it's got all that there?
Yeah, it's got that.
Cool. Awesome. And then we want to train our new machine learning model. So just click on the little blue button at the bottom. And it's going to have a bit of a think for a little minute. So what it's doing now is it's taking your sound and it's processing all of it, right? And it's thinking about how it's doing it. Cool. And then it's just having a look. And when it's finished doing that, it will tell us that we can start listening to it. And then when you say things at it, it will recognize your zerp, your flurble, and your sploink. I think it was sploink, wasn't it?
Yeah.
And it would tell you what that means. It would tell you in English what those words mean, right? Once it's listened to you. So what we're doing with the machine is it's actually called supervised learning. So we're giving it a bunch of inputs and we're telling it, this is the answer you're looking for when you hear this, right? So that's the sort of most basic form of it. You give it a data input, it recognizes it using an algorithm, and then it gives you the output you expect. The other stuff you can do, the really cool stuff you can do with machine learning that we might be able to get onto like in the future sometime, is where you just give it some info and then say, okay, go and work out what that means, right? So that's unsupervised learning, and that's like way harder to implement. That's like super duper complicated because you have to sort of think that computers are really dumb, right? Like everyone thinks computers are really smart, but they're not. They're actually super duper dumb, and they can only do exactly what you tell them to do. Like they can't do what you and I do and make guesses about stuff. They can't intuit anything. If they haven't been told, they don't understand, right? So like I could tell you how to go make a cup of tea, right? And you go, yeah, okay, cool. So I have to do all these things in the middle, right? I got to go turn on the kettle. I got to put water in it. I've got to do all this stuff. There's actually like lots and lots of steps in making a cup of tea, but you can intuit most of those because you know how it goes. Computer can't do that, right? So unless you tell it exactly what to do, go to the tap, turn on the tap, fill the kettle with water to this point, put the kettle on the stand, push the switch down, wait for it to boil, get me a cup, right? Every single step involved, the computer won't be able to do it and it will fail. So what we're doing here is we're telling it, here's what you're looking for. When you hear this, listen to it a bunch of times, understand what this is, and then I want this output from you every single time you get it. So we're training it just like you would teach someone how to make you a cup of tea, right? But the computer's doing a lot of the stuff in the background. We've got like some machine learning engines that do that. And so we're cool. So how are we going? Is it finished yet? Can we listen, or is it still training?
Yeah, I think it's trained.
Cool. So that means that what you can do now is that you can actually start listening. So if you click start listening and then say one of your gibberish words, it should tell you.
Verbal. Sploink. What's the report again? Oh, yeah, Zerp.
Try
Zerp.
Zerp.
Okay, I recognise.
Awesome. So it's working, right? So what it's done is we've given it all this gibberish input and it's gone away and it can say, oh, when you say that, you actually mean this. This is the thing I'm giving you back. This is the output you want when you say that, right? And we could do that with all sorts of things. So if you think about the Alexa in your house, right? If you've got an Alexa or a Google Home or any of those sorts of things, do you have one of those in your house? No? Cool. Privacy for the win, right? So with those sorts of things that you have in your house, when you talk to them, they listen to what you're saying and they go off to this huge database in the cloud that can sort of understand most of the things people say, and it can bring those answers back and do the thing you ask it to do. So we're kind of making a very basic version of Google Home or Alexa voice recognition here, whereas that one is massive and takes thousands of people to look after every day. And they have all sorts of issues with it, but hopefully we won't have that. Like we're not going to say Zerp to your voice recognition thing and it's going to order us a digger off eBay or anything like that. I'm pretty sure we'll say. All right, cool. So what you want to do now is we can go. Are you happy with how it's working? Like it seems to be working pretty much okay.
Yeah, it seems to be working.
Okay, cool. Because if it wasn't, we could go back and train it again. We could add some more voice commands to it if you think, oh, that one's not quite the way I'd like it. But if you're happy with it, we'll just crack on.
I think I'm happy with it, yeah.
All right, cool. So if you head back to project at the top left again, you see that text link.
Got it.
Cool. And then on the right is a button that says make. That's it. And so we can open a thing in Scratch now. So it will take us straight through to Scratch and we can open the project there. Yeah, cool. So it's going to boot up Scratch for us. And you'll see on the left at the bottom of your menu, there's like a whole new different menu that spits out black blocks if you have a look at it. It's the voice recognition list. There we go. Some nice new black blocks. So with these blocks here, we can just throw them into Scratch code, any old Scratch code, and it will recognize your voice now. Part of the machine learning model you've built has now been imported into this Scratch project. And you can just say like Flurble at it, and it will do the thing you want it to do when you do that. All right? So the first thing we have to do with it, though, is we have to train the new model. So go to your events block and grab a green flag.
You got it.
Sweet. And then under your voice recognition list, there'll be one that says train new machine learning model. Clip that under the green flag. That's the thing we have to have it do whenever we start the project. Cool. So it's going to go away to your database that you've made and bring in all that data for you, all those inputs and outputs, and say, okay, cool, these are the ones we're going to use for this project. I can do that. The next thing we need it to do, so it takes a little second, like we saw when you trained it before, that it had to wait a minute to do that. So grab a wait until block from your controls, and we're going to wait until it's actually trained the learning model for us. So cool. and then back to the machine learning list, and you'll have the is the machine learning model with a pull down menu. It's like the gem shaped one. Yeah, that's it. And make sure the pull down menu says ready to use.
Yeah.
Awesome. Cool. So what you've just built there is that when I click the green flag, go away, grab my data from the machine learning model, and then we're going to wait until it's ready so that we don't start spitting commands at it and it doesn't understand yet. It's going to go, yeah, cool, we're ready. And then you see a block that says start listening. So connect that to the end. And then what it's done now is once it's ready, it will start listening for the things that you say.
What is music?
Cool.
Okay, happy? Sorry.
No, don't apologize. You know, you could make like a robot dog that is actually trainable, right? So like you could make a Samoyed on your computer that like actually does what you tell it to do when you tell it to sit and stuff. And you can show your dogs. You'd be like, this is what a real dog does.
So you sort of do it. They only do if there's like a tree around. Which there
Okay.
is. So.
It sounds a bit like me, actually. I only do what I'm supposed to when there's treats involved. Awesome. So have you got, at the top there, you see you've got your like when I hear left, when I hear right.
Yeah.
So on our blocks there, it's telling us what we want it to be, whereas your made-up words are the things you need to say in order for it to understand that. So if you grab in a when I hear left and a when I hear right, we can make the cat take steps left and right in whatever way you want to do that. Like I know you're a bit of a Scratch pro, so however you want the cat to step left or right, you can do that using the code. You can make it change X or take steps, point in direction, whatever you want it to do when you give your left and right commands. So how are you going to make it move? What do you want it to do?
Let's see. So I'm gonna need that. I'm gonna need that again. And let's see. If I'm not entirely sure if it's the right way around. So it's simple, but it's would need sorry. Yeah, very distinct. Right, that might work.
Cool. Have you sure you got the right numbers in those change X values? Because
I'm not entirely sure how the chart works, so I'm not entirely sure it's the right way around. But
okay, so when you get a minus, it will move to your left, and when you give it a positive, it will move to the right of your screen. So you might want to switch those around to be positive and minus, negative the other way. That's the way. Cool. So we've got the green flag running by the looks, and it looks like the whole thing is ready. Oh, do you want to just click the little magnifying glass, Sophie, just to zoom in on your code a bit when you get a sec? There we go. Cool. They want to get involved. You should record them. Now that would be a fun project.
yeah, she does that when she flops, and currently she is. So
we could make a machine, right? That when hears the dog make that noise, it like activates a thing that drops a treat on the floor. That would be a pretty fun project. I don't think we got time to do that today, but we can definitely get together and do it another time. That'd be an awesome project. So if you give it the commands now, let's see if it does it. So what were they again? Sploink and Furble?
Sploink? No.
Not doing it. Okay. So let's give it a stop quickly, and then we'll reboot the project. Give it a green stop and a green flag. See if we can. So it's been a little bit laggy. So sometimes when you have the Scratch project up and it's trying to do things with the machine learning engine, it can be a little bit slow. But that's okay. We'll just give it a minute. Because it looks like your scripts are highlighted, which means it should be waiting for you to do the thing. But it could be it's lagging.
English. Left.
No, we trained it on Sploink and Furball. It should definitely be waiting for those.
Sploink.
Come on,
Furball?
Scratch.
Yeah.
I think it feels to me like it's lagging out because it won't let you stop it either, will it?
No.
Let's see. Okay, so it should be listening.
Sploink.
What is it not doing? Come on, Scratch. I hate when this happens. The first time I tried to do it, it lagged for ages. It took a very long time for it to work. So let's see. Go to your alien language blocks.
Sure.
Okay, so it's still listening. We've got all the stuff we needed to do. Let's see.
Last one. No.
Cool.
So, is it loaded by now?
I'd hope so, but I mean, it should be because I'm looking at your when I hear left and when I hear right scripts, and they're highlighted, so they've got that yellow outline, which means that they're waiting for something to happen. They're the active scripts, so it should be waiting for us to do that. And we tested your Sploink and Furball, and it definitely gave us positive result when we were playing with the machine learning engine.
Does it need
so
to
we know that it
start
works.
Does it need a start listening block?
So that's what it should be underneath the green flag. Where we've got that start listening block underneath your green flag, that should be what it does, and it should activate both of those when I hear right scripts, which is what it looks like it's done. It just feels like either it's lagging or maybe it's not hearing us very clearly. If you go back to your Machine Learning for Kids project, so the other tab in your browser,
Yeah, I've got it.
and you go back to project,
Okay, back to project. Oops.
and we go to learn and test. So test your machine learning model again. So train it up. We'll give it a sec. Okay, so it's training right now. And then when it's done, we're going to start listening again and try Splunk and Furball here, and we'll see if it does it. And if we're getting positive results, because it could be something to do with the mic having an issue, because maybe Scratch hasn't asked for permission to listen to the mic, but I don't know why. So have a go, start listening, and let's see, test it again.
Furball. Sploink.
See, it knows what we're doing. It's worked it out, but for some reason, Scratch is unhappy.
When I ran through the code, my Windows had a red mic button. This one doesn't. Do I need to enable it?
Possibly, yeah. Although usually Scratch would ask for permission to do that. I'm surprised it didn't. But then if you've already shared it, I wonder if it's because we're streaming together, it's hogging up your mic, but then the machine learning model would also not be able to hear that if that was the problem. Interesting. Jump back to the Scratch. I'll stop listening on this page before we go back to Scratch, just to make sure that we're not taking over the entire microphone. Can you stop the project on this page and just let it go dormant? And then we'll click the green flag to restart it. That's it.
So do I try it now?
Does it not? Will this project not stop? We might have to click the green flag again just to see if we can get it to reboot.
Okay, now.
Okay, so that's it. So while that's highlighted, it's training the new machine learning model. We'll give it a second. Try now.
Sploink. I think it's the wrong way. Oh, I see the problem. It's a dead cat. I need to turn it opposite way. What we need to change the app? we could try that.
Yeah, go for it.
No. But the cat's still tilted. We can change it. How do you untilt the cat?
Oh, if you just click the second block down, turn 15 degrees clockwise, he'll just turn back.
Yeah, that. So
Cool. So can you see that script is lit up around the edges? That means it's active. Cool. Now the other two are active. Give it a go.
Sploink. Yeah, it works. Just
Awesome. And can you make them go the other direction?
verbal.
Yeah, now we're talking. Cool. Okay, so it's off. It's working. Right. So now the third one. What did you want to do again?
It's Zerp.
Zerp. Okay, cool. So it's got no commands for Zerp yet. So what we need to do is go back to your alien language blocks, drag across when I hear teleport.
Right, my hair teleport.
Cool. And then we wanted to teleport, right? So how would you produce some blocks that would make the cat disappear from somewhere and reappear somewhere else?
Sorry, I think it's in looks. Like is it like a change effect by
Yep, so that'll make the cat change crazy colors. Yeah, so we can do that. So when you hear teleport, you can make it change color effect, or you can make it do whatever you want it to do. So that it won't disappear though; it will just look weird. So you could give it like a whirl, and it will make it look like it's spinning down the drain hole. Yeah, that's cool. And then if you did like a repeat on it, so if we got a repeat and made it repeat the whirl effect by X number of times, it will start making it look really whirly.
and then it hides.
Yeah, then you want it to hide. Yeah.
So hide.
And then have it go somewhere else.
This is motion. Go to random position.
Nice.
And then show.
Yep.
But don't we want it to stop whirling?
You want it to stay whirly when it gets there?
No, I want it to stop whirling.
Okay, so then what you do is you just reset graphic effects. So clear graphic effects will take it back to like looking like a normal cat. Cool. And so now if you try giving it the command to teleport.
Should I put the clear graphic effects here?
Yes, that would be a good idea. So that as soon as you boot the project, it would clear all the graphic effects off the cat. Yep.
Why is the cat going downwards?
It's hearing us say something it thinks is a teleport command.
Zerp. Yeah, it works.
That's awesome.
Okay, so that's training now. Sploink. Zerp. Verbal. Okay, it works.
That's awesome. That's cool. So cool. And then from there, obviously, we'd make it look a bit more sort of like we'd put a backdrop on it and stuff, and we could add crazy sounds. You could add a crazy sound when it teleports.
Yeah, we could. So,
well, so it's up to you, right? It's your project. But like, I tend to go off on one. When I start playing with Scratch, I expect to spend 15 minutes. And then about 2.5 hours later, I look up from what I'm doing and I've made some ridiculous gorgon of a project. That's awesome. And so, I mean, that's machine learning, right? So if you go back to your other project, any sort of commands you want to add, Sophie, you can just do that. You just go back and say train, and then you give it another command and give it 8 examples of that, bring it back here and boot that into your project. And you can have a completely voice-controlled video game or an animation or anything you want.
Yeah.
That was really cool.
So could we change the sprite?
Yeah, totally. Do what you want. It's your project. Yeah, go nuts. I'm not a massive fan of that cat. I find he looks very smug. I like to try a different sprite every now and then.
What one faces forward like the alien? Wait, is there an alien? Wait.
Something that faces towards us. Frank faces towards us. And the monkey.
Oops. We could give him Frank. So if we drag the code. Give me a sec.
Every time I hear a dog make that noise, I really want to make a project that does stuff when they make funny noises. That's going to be so funny.
Okay, now I have to get rid of the cat. Wait, let me just check all the codes up. Okay, so all the codes there.
Awesome. Yeah, see, look, so Frank's doing the same thing.
Now what we need to do is get rid of the cat. He looks overly smart.
There we go.
So, yeah, I've done that. You know, Frank's like belly only whirls.
So you could change the whirl effect, make a bigger number in the whirl effect, or make more repeats, and it will twist him up even more. It'll twist him up really big.
Let's try 40.
Yeah, cool.
Maybe a bit more. Make it more satisfying. Okay, that. Zerp. A little bit more satisfying. There, should be satisfying enough.
There we go. Are your dogs setting off the Zerp command?
It might be.
That's cool. Awesome. Well, that's wicked. That was really cool, Sophie. Thanks. I had a really good time doing that. And like, if you make anything more, share it with me, and I'll put it on the live stream. You can show everybody the crazy thing that you made. Like, if you want to do something on your holidays that's not cleaning up your bedroom, send your work to me, and I'll put it on the live stream. That'd be really cool.
Yeah.
So are you going to do any coding in your holidays, or like, is it literally just all cleaning bedrooms all day?
Basically all cleaning bedrooms and sleeping.
That sounds worse than school.
It is worse than school.
Amazing. As a teacher, that warms my heart, I have to say. Hearing that something else is worse than school, you don't often get kids say that, so it makes me feel really nice deep down. That was cool. All right, and thanks for being on again, Sophie. It was awesome to have you. I hope we can have you back again sometime soon.
Yeah, I'm sure you could, but thank you.
Not in the holidays, right? You're going to take your holidays off?
I could do it.
Yeah?
We're going to Scotland, so maybe not every week. But
Okay. Yeah, cool. No, I'd love to have you back. It's great having you on. You're really good at coding and stuff, and you come up with the best ideas. It's really fun when you're on. So anyway, I will see you next time. All right? Give your dogs a pat for me. All right? And don't do too much bedroom tidying while you're not here.
okay.
All right, I'll catch you later. That was awesome, right? So playing with machine learning, guys, it's not hard. It's a very advanced concept, and it's a very complicated thing in its essence. But for you to be able to work with it, there's a lot of opportunities for you to do that. If you want to jump on the internet and have a go, you certainly can. It's very, very easy. We've got the Scratch adaptation to it, and you can see there we made up our own words. We added different commands. We made things in Scratch. So if you can play with Scratch, then you can use machine learning to add really cool stuff to it and make something a bit different. So if you do make something amazing and you've played around with the voice controls and you want to make something, you want to share it with us, throw it on rpf.io/home. We'd love to see the stuff that you make. It's really, really cool when people share stuff with us. And we're going to have some guests on the stream in a couple of weeks who have been sharing their projects with us every single week, and we can have a chat to them, and you guys will be really interested to see the sort of stuff that they're doing, where they come from. And so we've got our guest here now. So Carrie Ann is here to see us, and we're going to have a quick chat with her about all the stuff that she's been doing. How's it going, Carrie Ann?
I'm good. How are you?
I'm pretty good, actually. I'm up in the peaks, so I can't complain.
Yeah, I feel like I haven't seen you in a really long time.
Yeah, it feels like ages. I was going to say that. It feels like forever, like I haven't seen you around. But
how good was Sophie?
I know, right? She's always good. Like every time she comes on, she's amazing.
Oh my gosh, I was blown away by that project. She clearly knows Scratch very, very well. Even I couldn't remember how to do some of those things.
Yeah, no, she's brilliant. And last time we had her on, we were making this turtle collecting pollution game, and then we started adding broccoli lasers and all sorts of crazy stuff. It got real wild. It was awesome. It was really fun. Lots of curveballs thrown and sort of problem solved. It was excellent.
Coding. That's the next step.
I know, right? I would love to make that sound recognition project with the dog, right? So the dog makes this noise, and it's like you could be able to make a dog translator, right? That would be so much fun. I would be up for that project. That'd be really cool.
I think the translation will just be more food.
I think, yeah, probably, yeah. Scratches, more food outside. Yep. But that's cool, that'd be all right. So it's great to have you on. Like, I know how busy you are. You're like basically non-stop all the time. You got so much stuff going on. Like, I mean, you had your Geek Girl Diary stuff, which loads of people will know you from. You've worked on CAS Include and stuff like that, which is like a massive deal, which I think is really, really important. And then the one that's super relevant for us is that you helped on Sonic Pi, which is one of the videos this week for Digital Making at Home as a Sonic Pi project. And I know that you were at the very beginning of that whole thing. Like, what was that like when it started off and it was just sort of like people working in garages?
Well, I mean, it started out, I was teaching. I was just teaching like normal in my secondary school. And I'd heard about this Raspberry Pi thing, and I started to sort of get my hands on it. And I was just introduced to this guy at Cambridge who had worked out that he could kind of turn a Raspberry Pi into a kind of music machine. And that's all I knew. And someone said, "Oh, do you want to meet him?" And I was like, "Yeah, why not? Why not? Send him my way." So he came all the way down to me. I was in East London at the time, and he came to my classroom, and he just showed me that he had turned this Raspberry Pi into a music making machine. And I said, "I'm really interested in getting my students to move on from Scratch, do all that cool stuff that they're doing in Scratch, but move towards something that's much more text-based. Text-based programming." But Python felt like a step too far at that stage with kind of children who were around 12, 13. So I wanted something to kind of bridge the gap. And at the same time, I was really interested in this idea of digital making and context for learning how to code. I think we're really motivated, and young people are really motivated by projects where you want to build something, you kind of know what you want to create. And then using code as a way to do it. So the idea of using music seemed really, really natural. Being able to compose music and make music using code felt really, really, really easy and a natural kind of move. So this guy called Sam Aaron, I should probably give him his name by now. We were in my classroom and we drew on a whiteboard a kind of IDE, kind of what it could look like, some text on one side and some outputs on the other side. Just as a starting point, and he went away, and in the space of a week he had written that, he had built it, and we had an interface. And from then on we just started to write lessons and see how the kids would interact with it. And some really interesting things happened with the first few lessons that we wrote. We introduced the idea of sequence, and we started to move through kind of the programming concepts that young people learn, or people learn as you learn to code. And one is variables. It's really common to learn variables. And we realized, we taught this disastrous lesson where we upfront said, this is how you make a variable. You can call your variable anything, and you can store notes in it. This is what a variable does. And the rest of the lesson was just these young people writing lots of variables with funny names. And we realized very early on that without a need for introducing a programming concept, there's no point trying to teach it. Don't introduce variables until you need in your game to be able to have a score, right? There has to be some sort of reason for introducing these things. So we learned very quickly a lot about how to teach programming. And this was, that was 2013. So it was a while ago. So that was kind of the origins of Sonic Pi, really. It was about music, it was about getting young people to code. And I think since then it's been on a much longer journey. I'm certainly not involved in it now, but it's been a real joy to see Sam take this idea and use it to both help people learn how to code, but also really excitingly help people live code music. And I think that's really, really exciting as well.
Yeah, definitely. A lot of that resonates with me too, because back at school, I was like, surprise, a terrible student. And so I was always that kid that was asking you, why am I learning this? Why do I care about this? Right. And so that whole, like, this is an end, like this is a thing that you can do in order to produce a thing. Right. And saying that you teach them the things they need at the time they need them. Like that's how I learned to program. Right. It was like, I want to make this thing. I need this portion. I need this tool or this ingredient to make a thing happen. I go away and learn what that is and bring that into my work. And that was like a very practical way to learn coding. And I think that's really important, because I found it when I was learning, like, with my dad talking to me when I was a kid, like he would get very cerebral about code and I would lose interest. It was like, oh, this is all just like ideas and stuff. It doesn't help me do the thing I want. Like, it's cool, but like, you're not helping me. And I found that when I came and did Picademy all those years ago, and that we had Sonic Pi put in front of us, it was like, I can make this thing do awesome stuff. Like, it can do stuff with very short amount of work. And the idea that you can read it as well, it's super readable using that Ruby code, and it's very easy to understand. And in about 5 minutes,
quite straightforward, like play and pause, sleep and stop, and those are repeat loop. It's kind of gone on a journey over, it's been developed by Sam, that language, but I just think that really helped. And indentation, oh my God, code indentation is, it's there to make things readable for you, but in some languages like Python, it's really important, otherwise your code doesn't work. And when you're teaching and you've got 50 minutes to teach young people something, you don't want them to have those stumbling blocks. You need to remove anything that is unnecessary to help them progress. So yeah, I'm totally with you. The language is amazing.
Yeah. And the eureka moment comes so fast with Sonic Pi 2, right? Like it's just there, like within 5 minutes it's going ding dong, ding ding dong dong, and you're like, oh cool, it's doing it, right? It's doing it. And that's what I loved as well. Like I think that was really cool. Like the fact that you can get into those sorts of things, like it's, I mean, you talk about those sorts of things in your crash course, right? You've got your crash course online about like getting it going fast and doing coding and like talking about big concepts and things and like.
Yeah, crash course is more kind of computer science. It's more kind of the evolution of computer science, and it's really understanding computer architecture. So going from, binary and, transistors and working your way through into building a computer. And we do touch on programming, but it's not kind of like what we do at Raspberry Pi. It's much more sort of theory based. So I think if you want a grounding in computer science, Crash Course is a really great series of videos that really help you understand the basics. And it has like fun animations in it, and it kind of helps you understand quite a lot of common language and concepts that are used in computer science.
That's cool. Yeah, definitely. What was it that inspired you to do the Crash Course? Like, how did you get into it?
I've always been a fan of Crash Course. It's kind of a big educational YouTube channel. I had my own YouTube channel. It's Geek Girl Diaries. I started that when I was teaching because I noticed my students weren't just searching, using search engines to find answers to questions. They were searching on YouTube. And it was kind of a real moment for me. I felt like I could use it to support young people outside of my lessons.
Mm-hmm.
You can pause a video, you can rewind a video, you can rewatch a video. So it meant I could provide extra support for my students. So I did tons of stuff on there. And then the producers from Crash Course just got in touch with me and said, look, we're thinking about doing computer science. Would be really great to have you involved. Would you be interested? I sent them a video saying I would be. I was really fortunate to just be involved in that, and had to fly to the US to do it, and spent 4 weeks filming back-to-back episodes of all about computer science. And it's really great to kind of do it in a different environment, in a different context, to really share how passionate I am about computer science, but also share it in a way that will hopefully resonate with the audience.
Yeah, it must have been exhausting filming 4 weeks back to back. That must have been killer.
Well, I didn't do all 4 weeks back to back. I did them a week each.
Okay.
But yeah, it was 4 weeks worth of work.
All right, that's heavy. Yeah, no, being on camera is surprisingly tiring, right? Like, right? It takes it out of you. Everyone's like, that's so easy. It's like, no, man, it's not that easy.
It's really not.
Yeah, that's cool. And so you don't have a comp sci degree, right? Like I don't either, but you're not academically based in comp sci or anything like that. How did you get into it then? How did you become the great Carrie-Anne Philbin?
The amazing Philbin, I think.
Well, that's how I introduce you to everybody when you're not around.
Look, when I was at school, I suffer from something that I think a lot of young girls suffer from, particularly teenage girls, which is kind of unconscious bias that's around us, kind of, stereotypes, threat, all these things that are really well known. I was good at maths, but I didn't realize I was good at maths, and no one told me I was good at maths. I was good at physics. Again, no one really told me. I kind of was in the top sets, but it didn't really resonate with me. And I felt like I was terrible at them. And yet I had this kind of love of making and doing and building things, and I'm a very creative person. No one really reinforced the kind of STEM aspect of those skills. What was reinforced to me was humanities, arts, even by my own parents. I mean, I'm very fortunate I grew up. The reason why I'm not afraid of technology and tinkering and electronics is because of my dad. He has a big influence on me, but I learned those things from him. But still, my parents encouraged me towards arts and humanities. And I think that is just completely subconscious, and just a sign of those times that's kind of how it was. So computers were always part of my life. So even when I was at university studying a humanities degree, I was in the computer labs, messing around with computers, and I would go to LAN parties and drag my computer with me to LAN parties. And I learned all this stuff kind of on the side whilst I was studying. So I think whatever discipline you end up studying does not, embrace all the other things that are going on around you at university, because you never know where you're going to end up, right? You don't pick, unless you're doing some sort of medical degree, you don't always end up in the field which your degree is in. So keep it freezy and try and, get involved in everything.
Yeah, the world is big, right? And there's a million ways to skin a cat, right? So
Right.
yeah, that's really
It's
true.
the same as me, right? We don't have
Yeah.
formal qualifications,
Yeah.
but we are very knowledgeable now. So
Yeah, LAN parties, man, that's a blast from the past. They were so much fun.
massive monitor as well. I've been trying to find pictures.
And the enormous spaghetti.
I'm like, oh, where are the pictures of like the massive CRT monitors we used to drag?
Yeah. Oh man. Yeah, I remember that. That was so much fun. Just spaghetti cables all over the floor and public folders with stuff in. Yeah, good fun. Good times. That was really fun. That's really cool. And so do you think that unconscious bias, the idea that girls aren't told they're good at physics even when they are, then do you think that's changing? Is that no longer the status quo? Is that being shifted, do you think?
Well, I think there's been a massive focus on gender within STEM education for the last sort of, 10 years. So, I think it will slowly change, and there are lots of organisations. The Raspberry Pi Foundation is one of them. There are others like WISE, Apps for Good. There's so many, Code Club. Everybody is thinking about how do we improve the gender balance. So I think it will naturally improve over time. I think we are seeing the impact that Code Club is having and Coder Dojo are having on increasing the number of girls. So I think it's a slow burn, but I think it is coming. I think we need to now think about how do we extend that to reach, other diverse groups that aren't represented, right? And that's really important as well.
Yeah, I was lucky enough last week to be able to speak to Sue Black about the work that she's doing and stuff with that. And that was amazingly inspiring. That was really great to talk to her. And I know that CAS Include is a big deal and it's a thing that you work and you're quite passionate about. What exactly is CAS Include about? What's the mission of it and what are you guys aiming to get? I mean, obviously the gender balance, but how are you sort of working through to change that?
So computing at school is for teachers. It's a teacher kind of organisation. It's a group it's very grassroots. It's lots of people who teach computing who kind of come together and share best practices. And within computing at school, I have a working group that's called CAS Include, and we focus on how do we support teachers to ensure that they have a classroom that is inclusive, that they are teaching using the best research, most up-to-date research to ensure that they are not disenfranchising anybody. And that's really, our focus is on teachers. But I think anyone can learn, whatever type of educator you are, if you're a volunteer or even a parent, I think you can learn from a lot of that research. So, to go to computing at school, you can kind of access some of the stuff we've done. But we're also doing it at Raspberry Pi as well. And through the National Centre for Computing Education, we've got a lot of outputs kind of on this that can support everybody.
What have you found as sort of one of the key things to address that unconscious bias that we found in schools and sort of that has been the norm up until now? How would you suggest people sort of address that bias with their own kids, perhaps?
I mean, you have to make the unconscious conscious, and that's the hardest barrier to get over. I think you need to be aware of the biases that you're not aware of, and that's one of the hardest things to get over. Typically how we do it with young people is we ask them to draw a picture of you could say an engineer, a computer scientist, a physicist. You could name some some jobs in the STEM industry, and typically everyone will draw a very similar picture. Someone in a lab coat, typically a man. They usually have glasses. You can ask them to write words around it, like descriptive words, adjectives about what is it like to do that job. And then you can kind of collect those together and say, oh, okay, let's look at the common themes here. And then you can really address those misconceptions that people have about those roles, and then show them real people working in those jobs, real women, real people of colour, people who have come from poor working class backgrounds into these industries and done very, very well. People need to see people like them. I really believe that. You need to be able to see someone who looks like you or has come from the same background as you to realise that is a route for you to get involved with. So making those unconscious biases conscious is very, very difficult, and it takes a long time, and we all have them, we all do, and it's about really thinking and being mindful of what they are.
Yeah, that's really interesting. I mean, I think talking to Sue last week, she was saying very much the same thing, right? About the being positive about your consciousness, the understanding of the things that are going on around you and things like that. Do you feel that was a problem when you were coming up through school? Like you were saying just now that you didn't feel like you were good at physics or good at maths. Was that part of the entrenched establishment, without even knowing perhaps? Or do you think it was for a long time it was a deliberate thing that we're now just seeing tapering off and changing in that way.
Yeah, I don't think it's deliberate at all. I definitely don't think it's deliberate. I mean, there are lots of really lovely men, you know, in the industry who kind of scratch their head and always come up to me and ask me like, oh, I really do want more women in my team. How do I make it happen? So there's genuinely people aren't aware of what those biases are. And I think the point is they start when children are born. You know, we're so entrenched in our culture, and it takes a long time for those things to change, and they will only change if we are very active and passionately active about changing those things and making sure those are based on evidence and research that show what work. You know, I think we've been stumbling around in the dark for a little while. We have ideas about interventions that we think will work, but we need to test those interventions and really check if they do work, and then try and make sure they're implemented in education.
Yeah, I mean, I personally feel, I don't know if you agree or not, but the fact that technology is now so pervasive in our lives, right? Everything is technology, that the democratization of it is almost like a necessity now. Like we can't afford to not have that diversity in tech anymore, because we're continuing something that will continue to be non-diverse if we're not actively working on changing those things, because technology is literally everywhere in everybody's lives now.
Yeah, and all that technology has been developed and designed by white men. Like, that's factual. We've got evidence that shows that, right? So if I'm not making the technology, how is that technology serving me? And that is why all young people should have access to computing education. They need to understand the technology that is around them so they can solve problems that are meaningful to them, right? The 4 R's are reading, writing, arithmetic, and Raspberry Pi.
Nice.
Everyone. And what I mean is everyone should have a grounding in computing and computer science.
Yep, definitely. Like, it's like, I'd say a couple of centuries ago, you could get away with saying, oh, I don't need to read and write. You know, there's a scribe, a guy up the road, I'll pay him some money and he'll write the letter to my grandma. And when it comes back, he'll read the reply to me. But that sort of illiteracy today would be unconscionable to most people. And I think we're seeing that shift into technology literacy being the same, right? Like, you have to know the world you live in is a technological world. Everything you do, thousands of times a day, you interact with technology. And if you don't understand that system, then you can be taken advantage of, or you can be isolated or ostracized. And it's a really dangerous thing. Like, I think the work you're doing with like computing at schools is like really vital. I think it's super important.
And just to bring it back to Sophie's project around machine learning, I mean, that is, machine learning and AI is now becoming a really big part of our lives. We need to make sure that what those machines are learning are representative of the world, right? Otherwise, it's a dangerous place we live in if they don't.
Definitely, yeah, that's really true. And that's like, and you are seeing instances where machine learning is very biased, right? In its own nature, the nuts and bolts of it having been built, the way it is made makes it biased. And that's, again, comes back to the diversity that we have in the industry. And I think it's just going to be a virtuous or a vicious cycle unless we get control of it. I think it's really important.
Yeah, I think the future is bright if we, really educate young people. So I'm a big fan of education, as you might understand.
Yeah, me too. Knowledge is power, right? And that's the thing, definitely. Brill. Thanks for being on today, Carrie-Anne. It was awesome to talk to you. Like, even though I haven't seen you in ages, I didn't have a beard last time you saw me, right? This is my isolation beard.
Who's that? So... Oh, no,
yeah, brill. All right, cool. So thanks for coming on. I'm sure I'll see you again soon. But until then, be safe and I'll catch you later.
Yeah, thanks for having me. Bye.
My pleasure. Later. Awesome. So great to talk to Carrie-Anne. Like I said, I haven't seen her in so long. She's such a cool person. And the discussion around diversity is ongoing, and everyone's making strides where we can. And I think if you're involved in it, then that's awesome. And if you're not, then you definitely should be trying to get in on it. And we'll see you again next week. So share your work with us at rpf.io/home. Jump on the digital making at home stuff. Have a look at our videos, all the different projects we're releasing every week. There's new content for you to try out at home. And even though we're starting to get outside in the world and stuff, that doesn't mean you can't spend some time in your room and make something awesome. Get online with us and have a watch a couple of our videos. And we're always releasing new stuff every week, everyone. And we're doing our live stream every Wednesday at 2 p.m. So join us next week and I will see you then. Catch you later, everybody. Be safe. Bye.